In this video, we're gonna just correct some errors and just let's see where we're gonna take this. Something about line collision, boundary collision. We'll be talking about that one. We're gonna create nice code. Okay, let's do some rectification. I might have already done some. Let's see where I did rectification. Okay, I included theta 1 and theta 2. Okay, theta, that is angle that loss vector makes. Kept it 0. Particle 1. I can do it in the same thing. Or different thing. That's what I'm gonna talk. But how can I do it? Maybe I can do it in one. I don't have to go for two variables. Just go for one variable. Just do you always do like this. Okay. Theta 1, theta 1, and here theta 2, theta variable and second element. Actually, that is what it means. This was not there. This is actually I included it to be just more readable. Okay. Okay, acceleration. I'm gonna go for this one also. Keep it nice and good. Two particles are there. Just keep it 0, 0. No acceleration. This thing doesn't matter if it is 0, 0. It doesn't matter. Okay, initial state. Okay, let's go for now. Initial state is always good. Now go for state. Yeah, I have made this one error in here. I made error previously. I corrected it. It was all rows first. This time it's like because position vector of a particle is first row. First particle is first row, all columns. That's what it says. First row, all columns. That time I made a mistake. That is, this is the first mistake I made in previous video. First row column, that should be like second row, that second particle, all column, giving it some size 0 minus 0.5, and in this range it should be, then this will collide. And there was second error, the theta 2, because I'm gonna y2 minus y1 x2 minus y1, it is given in slope is given in radians. I have to convert it into degrees because I'm working in degrees here, so I have to go for degrees. So I have to, in order to convert radians into degrees, you have to multiply into 180 multiplied by pi. Okay, I think rest I didn't do anything else. I hope so. Okay, let's see last one. In here did I do any changing? No, there is no change in here. Let's run the code first. Okay, let it run. It's gonna go back. Yep, that's correct. That's if you want it to go from like this origin at 45 degree and collide it with middle. You can change the theta here, dcv, so it should be theta is equal to 45, and another thing theta with respect to 5 will always be 90 minus if 2d. Then if it is actually in 3d, then we can actually take sum of squares of direction cosine is equal to 1. We need two angles and one can be calculated from that one. In here we only have two, third one we don't have to care about that one. Okay, it's actually here, but put it here, so change the x coordinate of y coordinate of first particle. We can change it here, keep it 0. Okay, this collides. Okay, there is some error, complex values are not. Okay, we can do one thing. I know it's, let's see what's happening. Okay, let's go for u. How many times it's running? Let's see how many times is this code running. It should run only one time. Collide. So this code is running 3 times and then it should run only one time. So it's in that range. I just put it in this range, so this particle is getting in that range 3 times. So maybe I can change one thing. I can go for, in this, while I'm doing collision, I can actually update the position vector. Position vector 1, okay, dt, same, u is new one. Let's see if it works out, but there is 3. Maybe I need one more. Yep, now it's working good. You saw that one, because it was running, it was in that range, because I was not updating for the next iteration. So I just put it there, so next iteration is updating automatically. don't need to, so second error has been rectified. Actually I want to just collide a particle with a boundary. Okay, this thing is cool, so two origins. Okay, so I can now collide particle with boundary. How will I do that one? Okay, let's see. For both the particles I'm gonna run for loop. For I is equal to 1 to number of particles. The number of particles would be given by I haven't given any input. I can calculate from mass, size of, or length of m, whatever is the length of m, but along m comma rows. Okay, m comma 1, I will show you what is the length of m comma 1. It will be same as number of particles. Comment it out and you can see that this next time. Length, it's not length, it's no, I'm gonna find length. I think, what is that function for len is for python maybe. Range, we go for size of 1 comma 1. Size, I know it's size will also work. Two, so two particles are there, you can see that one. So I need to run for loop for two iterations or whatever number of particles are there, size 1 comma 1. If I'm actually including line particles, that's if I'm going to go for line particles, I'm going to go for adding particles along for the same particle, adding another like another particle to the same particle, another particle, not like that, like adding another coordinate to a particle, so it will be along column, so along rows it won't add. So for line particles or surface particles I can also do like this, along size along row only, because along row number of particles are included. So if for I is equal to 1 to size I have to include I in here, no, just include. So I have to go for check position vector. Okay, if position vector of, so I'm going to talk about first one, not one, I, whatever the row is I throw, and all column is okay. Let's see what is the bound like. Bound is like lower limit, upper limit. So if I is greater than or equivalent to bound I first particle, okay, but the bound is not for different particles, the bound is the same, so I have to include first this is upper limit, all columns. If this is greater than this, or this vertical line is like or PVI is less than, this is upper limit, this is lower limit. Which is the upper limit? Wait, first row is lower limit and second row is upper limit, so second row is upper limit. This second row, there is first is less, here is less than. Okay, if this is greater than this or this is greater than this, but I shouldn't put it equivalent to because at origin they will be equal. Okay, if this is this theta 2, that time I need, okay, then I need to run this code. This code, but I will change something. Wait a second. So first of all, theta 2, velocity of the boundary would be, not velocity, theta would be 0. Even velocity would be 0. It's not like that would move. Okay. PI, I can change only that PV. So the second won't matter, whatever is happening to this thing. So coordinate is like m1 and m2 mass. That has to be very much. Let's put it like very much. u1, okay, u1, m1. I have to go for mi 1000. ui particle is, I'm just seeing that it will work or not. velocity of particle 1, velocity of particle 2 is equal to 0, direction cosine of this theta of this one, theta of first comma 1 comma 1. Okay, wait a second. I have changed this one also. Wait a second, because I have to go a cos x a cos d direction cosine how I written it 1 comma 1, it's talking about this direction cosine. Okay, and the second direction cosine I'm actually going for this one, so whatever is in with respect to x, so I can actually work that out also. That's good. So I can go for 1 comma 1 and go for I comma 1 out 4 I comma 1, and there direction cosine of that one, it doesn't matter, I'll go for 0. Theta 2 0, direction because at rest for boundary doesn't matter. Out is equal to collision. Today I have to see what the values here. Maybe it will work or it won't work. Direction cosine of this DCB, that is cool. That is the thing I have to just change here. So u would be, I'm just interested in the first one, out 1 and out 2. I'm just interested in u of I throw comma all is equal to out 1, rest I don't care, second particle out 1, or I can go for I out I particle, but out has only 2, first or second. If 2 are colliding, it should be 1 or 2. If 3 cannot collide, maybe it won't work for 3. So out has to be 1 or 2 here. Okay, DCV, I am only concerned about ith row comma all, means this first row comma all is equal to this, and this much I don't need. Out 4 I don't even need that thing. So cos of out 3, always out 3, and this one is 19. Okay, so x, y, and z. Okay, so if I actually go for that one, it's gonna update. That's also cool. Okay, I could just update the first. Okay, I first row comma all PV, not all. I just go for ith comma first, ith comma second, and ith comma for first particle. Okay, likewise for second, I comma all. Let's hope it will work. Okay, I comma DCV dot product. U has 2 components that I don't need. I need only the first one. I need this much. Columns dot product with, here I write I and ith. It means first comma wait, won't even matter, dot product. Okay, all ith comma all rows, and direction cosine is first, second, or third. Okay, this is okay. Let's hope this works. Maybe there should be no error. Okay, let's run it. Particle 2 is gonna collide. Okay, it's not coming back. Come back. Let me. Is it not working? If this. Let me display work. Work is not working. For a if PV I comma this one. Let me say this thing. I see this. Keep it there. Let me see now. PV I comma. So when is it getting greater than this 10? Position vector of, let me go for 2 only, not go for 1. That is colliding actually. Now the position vector of 2 is changing. 6, 5, 6, 5. Okay, this is the thing actually. Starting, what was it? 10, 10? 10, long time it will be 10, 10, what I can do. Okay, here. 9. So particle 1 is going. I thought particle 2 was going in front, particle 1 is going front. Yep, there it is, 24, 14. The thing is, if only one can get outside the limit, it should stop. If not everything. Yep, I will go for something else. Now show me PV I1 logic only. Yep, if only one can get element gets out, it should go. So if PV or this, I have to say that if only one element is 1, so I can create something else. I'm going to create a logic and call it this, and let me see the logic now. Okay, so logic is like particle 1, particle 2. So logic 2 I'm going to create is from the sum of logic all. Let me see. Yep, 1. If logic 2, now I'm going to create a reason. If control C is greater than equivalent to or greater than 0, this should go like this. Okay, let's see. Collide, work. Okay, now it's working, but it's not coming back. Working. Okay, at least I'm going. It's going in this loop, so I have to bring it back. Now that is the case because I had to go for minus here. Not minus. That should actually change. This should have actually changed. So collision is not good. Let's see the values. Okay, and do one thing actually. Make it 0. Keep it y as 10, and now simple. Me too. Okay, let's go for second one. Okay, so if I go for second one, it's positive. It's working every time because and theta is 180. Let me go and just see which one works. Or I have to do something else. Not coming back. Okay, something is not working well. So am I keeping masses very much? Why? Theta, I'm just interested in this part. I'll just make it come back. So I have to create another function. Let's create that one. Okay, let's call it function gives, yes, I need two values. One I need p comma theta and call it boundary collision and give it value of, wait a second, if something is gonna hit someone, half of m1 v1 plus, no, not half of m1 v1 plus initial z, this is 0 for boundary 0 0, so it will be same, just the reverse. So why would I need even to make this thing? I just need to reverse it out. I don't even need this much. I don't even need out. I'm just gonna reverse it out. UI is equal to minus UI comma all DCV is equal to same thing, so minus. Let me see what will happen now. Working but not coming back. That is good. It's not good actually. Something not working then. Okay. Okay, so there's cosines have to be done like that. Okay, only U has to be changed, not direction cosines. Because both are changed, they will just cancel each other out. And okay, it's working well. Now keep it at some angle. Let's see. It doesn't matter at any angle, they have to come back. Okay, theta is like 45. Array move with up view is working. Double V1. Okay, I now understand now what's happening. It has only one answer that time. Okay, it's working nicely now. So boundary collision is also working.